Hey class, we continue on with our mole calculations. This falls under our mole calculations. This is about empirical formulas and molecular formulas, and it's actually pretty formulaic. It's not like you have to learn a whole new concept. I'm just going to take you through basically a set of steps. So let me introduce both empirical formulas and molecular formulas to you. So an empirical formula is very simple. It's actually just the lowest ratio of elements in a compound. Excuse me. So that sounds like pretty ridiculous. Okay, some examples of empirical formulas are, of course, like when we have sodium and chlorine. Of course, you know already that's +1 and -1, so that it's just NaCl. You could also talk about BaCl2. These are all the lowest ratio. This would be a 1-to-1 ratio. This would be a 1-to-2 ratio. And if you think of it like fractions, you can't reduce the fraction anymore. So 1/2 is, you can't reduce that to any further, of course. So molecular formulas actually, like the actual true formula. And sometimes the molecular formula and the empirical formula are the same, such as BaCl2. Okay, sometimes it's not. Take a look at H2O2, okay, or C2H6. So this right here is hydrogen peroxide. I'm sure you've heard of that before. Whereas the empirical formula would be just HO, because when you have 2/2, it's the same thing as 1/1, right? So sometimes the molecular formula is not the lowest ratio. Just like in C2H6 is called ethane. Ethane has an empirical formula of CH3 because, I'm sure you recognize this already, 2/6 can be reduced to 1/3. So I always think of formulas similar to fractions because they kind of work the same way. So now that we have a very basic understanding of what the difference between an empirical formula is and a molecular formula, let's talk about how do we get an empirical formula. And then in an example, I'll show you how to find the molecular formula then also, which is just one step further. So an empirical formula, we have 3 steps. So this is called finding an empirical formula. Okay. The first step is, now you're going to be given a problem that usually has percents. Now it can be percents of elements in the compound, and what you're going to do, percent of element in the compound, and you're going to divide. So our step number 1 is the percent of the element. You are going to divide by the element's atomic mass. So you will need a periodic table for this. Okay, that's our first step, and that's going to be in green. The second step is going to be in red. When you have divided all the percents of those elements that are given to you in that compound by the atomic mass, and I'm going to show you examples of this, of course. Excuse me. Then you're going to divide by the lowest number. So each one of these numbers that you get after you divide by the atomic mass is going to be divided by the lowest number that you get. Okay? Again, that doesn't make much sense, but I will show you exactly what's going on. Now, here's what I like to do. There's really just 2 basic steps. There is like an addendum, though, like a second part to this that is like maybe, let's call it 2A. Now, if you get any kind some kind of 0.5, whether it be 1.5, 2.5, even 3.5, okay? If you get any kind of 0.5, then you're going to multiply all of them 2. Okay, now once you get these numbers, these numbers after the 3 steps, or after step 2a, and you won't have to do 2a. It's only if you get a 0.5. These numbers are the subscripts of your compound. And that's an exclamation point. So what you found are the ratios of those elements in the compound. So, okay, so you read through this doesn't make any sense to you at all. So let's apply it. Let's actually do a problem where you have a certain amount. An oxide of chromium, okay, is found to have the following percent composition. So percent composition is the percent by mass of both elements. That would be chromium and oxygen, okay? And for chromium, it's 68.4%, and for oxygen, it's 31.6%. Okay, so we found the amounts of each element in this compound, and there's only 2 of them, which is nice. So what I'm going to do then is I'm going to look at a periodic table, and I'm going to see that chromium is 51.9961 on my periodic table. It might be slightly different on yours. And in the first step, which is why it's green, I'm going to divide by 52.0 because I rounded off. Okay, that is the atomic mass. Now we always know that oxygen is a -2 in compounds, and it's 16.0 for atomic mass. You should start to learn a lot about oxygen because these things are common and we use them pretty often. So let's take a look at the calculations that we're working on. 68.4 divided by 52 gives me a number of 1.315. Now I try and take this out to a couple of places so that we don't lose much accuracy like that. I'm not really counting significant figures. I'm just making sure I have enough so that my numbers at the end will be reasonable. So 3, 4 significant figures works really well for this. And then I take my 31.6 divided by 16.0, and I get 1.975. So 1.975. Now, that's the first step. So now we're going to do the second step. The second step is divide by the lowest number, okay, and that's going to be in red. So clearly between these 2 numbers here, the lowest number, or the lower number, is 1.315. Okay, so it looks like I'm going to get a 0.5 immediately here. So all I do is take the 1.975 and divide that by 1.315. My answer is 1.502, which is close enough to 1.5. So I get a 1 here because 1.315 divided by 1.315 is a 1, and 1.975 divided by 1.315 is 1.501 or 1.502. So that is close enough to a 0.5. Now, here are my subscripts, but we never have a decimal in subscripts. So to get rid of the decimal, I multiply both of these by 2, and that gives me a 2, and this gives me a 3, which means that what I have then is chromium 2, oxygen 3. Okay? These are the subscripts for my compound. This right here is my empirical formula and my answer. And that's how you do these problems. So let's take a look at just one more here. I'm going to do 3 examples for this problem and for this sheet, and that's like almost half the number of problems that you have. So you should be able to do this pretty good. So let's keep going. This says percent composition of a compound was found to be 63.5% silver and 8.2% nitrogen, 28.3% oxygen. So I'm going to start off, less talk, more work, 63.5%. nitrogen is 8.2%, and oxygen is 28.3%. Okay, so I know to divide this one by 14.0. This one is 16.0. I'm going to pick this up just a little bit. Silver is 107.9 is what I get. 107.9. Okay, so I go through, do the math for each one of these. 63.5 divided by 107.9 equals 0.5885. That's fine. 8.2 divided by 14 is 0.5857, and 28.3 divided by 16 is 1.769. I divide this by the lower. Like that. I divide this one also by the lower, like that. This is going to be 1 and 1. I know that this one up top here is just a little bit more than 1, but these are subscripts, so we're just going to keep going, which means that they should be very close to the whole numbers, which it is. So I divide this one by 0.5857, and what I get is something very close to 3. By very close to 3, I mean that. Okay, so that means that I can just round them off to whole numbers. At this point, there is no 0.5s. Oops, I didn't break them up into colors. Sorry about that. So that means what I have then is Ag with a 1, N with a 1, and O with a 3. So this would be silver nitrate. Excellent. Okay, I'm going to pause it there, and then we'll do more with the molecular part.